Welcome to another edition of Mr. Pi the Math Guy, and today we're going to be talking about the area of circles and sectors. The area of circles you could really talk about in any level math starting in middle school, but getting into the idea of sectors is more of a high school geometry class. So let's get this geometry party started. Theorem, area of a circle. One thing you might not know is that area formulas, such as the formula for the area of a rectangle, or in this case the area of a circle, they're actually theorems. We call them formulas because that's how we use them. We know one of the two variables, in this case the area or the radius, and we can see here the area of a circle is the product of pi and the square of the radius. Pi, Mr. Pi the Math Guy. So here we're talking about the area, and that's equal to pi r squared. That's probably how you're used to hearing it being said. And remember, radius is half of the diameter. So if you're given the diameter of a circle, you're going to have to find the radius before you proceed. Example 1t. A circular archery target has a 2-foot diameter. It is yellow except for a red bullseye at the center with a 6-inch diameter. Find the area of the yellow region. Round your answer to the nearest whole number. We just read. I've in recent videos used the idea of RISE, where we read, illustrate, solve, and explain. In this case, we just read the problem. One of the key things I like to do is highlight, underline, identify the question. And in this problem, the question is right here. We're told to find the area of the yellow region. Now this is an application of the area formula, and so we'll be working with area is equal to pi r squared. By the way, this video is being made on Pi Day 2012. So area is equal to pi r squared. So we need to find the area of this yellow region. Now this turns out to be pretty easy thing to do once you understand the big idea. And the big idea here is basically a kind of part minus part equals the part we need, or the part that we need is equal to the whole minus a part. We have two parts here. We have the yellow part and we have the red part. To find the area of the yellow part, we have to find the area of the whole region, which would be the area in essence of the yellow and the red. And we have to subtract away from it the area of the red. So the area of the yellow is going to be the area total minus the area of the red region. So the area of the yellow region is equal to the area of total minus the area of the red region. So basically we have to find some areas and subtract them. So I'm going to show the work right here for the area total. This is a pretty easy thing to do. What we want to understand before we proceed is that these are in two different units. So we have 2 feet and 6 inches. So we either need to find the area in feet or we need to find it in inches. I'm going to do it in inches. So I'm going to convert this 2 feet into inches. So that'd be 2 feet times 24 inches per feet, or per foot. And that comes out to be, and that's not 24 inches, I just said the answer there. That should be 12 inches per foot to give us 24 inches total. So we know the diameter of the total region is 12, but we don't, or is 24, but we don't need the diameter, we need the radius. Remember, the radius is 1/2 of the diameter. So if the diameter is 24, if we divide that by 2, that gives us the diameter that we need, 12 inches. So we need to find the area of a 12-inch circle. And that's real easy, and that's going to be our area total. The area total is the area of a circle with a radius of 12 inches. So that's going to be pi times 12 squared. And that, of course, gives us 144 pi. I'm leaving it in terms of pi right now. The area of the red region we're told that it has a diameter of 6 inches. So, if it has a diameter of 6 inches, which is the distance all the way across, it's going to have a radius of 3 inches. So we have to take that to find the area of the red region. We have to take that radius of 6 inches, or that diameter of 6 inches, and divide it by 2 to get the radius. So the radius is equal to 3 inches. So that would be pi times 9 squared, which of course gives us 81 squared, or 81 pi, not 81 squared, but 81 pi. So now we can use this equation we wrote at the beginning, that the area of the yellow is equal to the area total minus the area of the red. The area of the total is 144 pi. The area of the red is 81 pi. So the area total is going to be equal to 144 pi minus 81 pi. When we subtract those two, that gives us 133 pi. And when we punch that in our calculator, because we're told to round the answer to the nearest whole number, when we punch that into a calculator to the nearest whole number, if we use the pi key, that gives us 418. Now this answer is if we use the pi key. If you use 3.14 instead of pi, you lose some accuracy, and you end up getting 424. Sector of a circle. A sector of a circle is bounded by an arc of a circle and 2 radii to the arc's endpoints. So if we look at this diagram right here and take a look at this definition of a sector of a circle. Okay, it's bounded by an arc. In this case, that would be arc BC, and 2 radii. In this case, that'd be radii XB and radii XC. So here we have a colored in. This is the sector we'd be referring to. A sector is named by the endpoint of an arc, in this case B, the center of the arc X, and then the endpoint of the arc C. So in this case here, it's similar to naming an angle. So here we would call this sector B, X, C. We could also call it sector CXB. Theorem, area of a sector of a circle. Take 1. Action. Here we have another theorem. The area of a sector of a circle. Gets kind of wordy there with those 2 prepositions of. The area of a sector of a circle is the product of the ratio, the measure of the arc, over 360, and the area of the circle. The area of sector BXC is equal to the measure of arc BC divided by 360 times pi times r squared. So in essence, what you do is you find the area of the whole circle, then you multiply it by the fraction of the circle that this arc takes up based on its degree measure. In example 2, we're asked to find the area of sector ACB. Leave your answer in terms of pi. Remember, on this Pi Day 2012, we're going to leave our answer in terms of pi. So the area of any sector is equal to the measure of the sector over 360 times pi times the radius of the circle squared. So in this case, we need to find the area of sector ACB, this region in here. We're told that that central angle has a measure of 100. Therefore, the measure of this arc is going to be, and that shouldn't be a word sector there, that should be the word arc. That should be the measure of the arc. And when I substitute the measure of arc AB in, it becomes 100 over 360 times pi times the radius squared. In this case, that'd be 6 meters. We have to square that. So over here, I'm going to start to reduce and square some things and work with everything but the pi. We'll save the pi for the end. So here, when we reduce 100 over 360, well, we can knock off zeros because they're both divisible by 10. At the same time, I'm going to square this here, and this is going to give me 36 meters squared. And what you can notice here is 36, and if we imagine this is over 1, 36 and 36, they can divide each other out, leaving us only one number, the number 10. We bring down the pi, and we bring down our units, meters squared. So the area of this sector right here is 10 pi meters squared. If we multiply that out, that'd be, of course, like 31.4, but it asks us to leave the answer in terms of pi, so it would be 10 pi meters squared. Here we define a segment of a circle. A segment of a circle is bounded by an arc of a circle and a segment joining the endpoints of an arc. So here we have arc AB and we have segment AB. And the shaded region would be a segment of this circle. I guess we would call that segment AB of this particular circle. What we're going to see in the next example is how to find the area of that segment. Here we are in example 3T. We're asked to find the area of the shaded segment. Round your answer to the nearest tenth. So we just saw that a segment is a part of a circle where the endpoints of a segment are on the circle. Here we need to find the segment of the circle related to segment AB. Now to do that, we're going to have to find the area of the sector of the circle. Now the sector we have to find the area of is this sector right here, sector AOB. I'm going to drop this blue in here so you can see what's going to happen. We need to find the area of this segment. To find the area of the segment, we have to find the area of the sector first, sector AOB of this circle. Then we find the area of this triangle and we subtract it from the area of the sector, and that leaves us the area of the segment. So we could write a little equation right now that the area of the segment is equal to the area of the sector minus the area of the triangle. Okay, the area of the sector being this pi piece, if you will, and then the triangle AOB or ABO, it doesn't really matter. So we're going to have to find the area of that triangle and the area of the sector. So we're going to find the area of the sector first. In finding the area of the sector, first we have to figure out how many degrees the related arc is, and that would be arc AB. And you can't really see it right now, but the central angle is 120 degrees. So therefore, the measure of arc AB is 120 degrees. So that's how we find the area of the sector, remember, is the area or the measure of the related arc over 360 degrees multiplied by the area of the circle given by pi times the radius squared. In this case, the radius is 24 feet. And we're just going to put our units on in the end. It's going to be square feet. So when we go to simplify this, 120 over 360 can be reduced to 1/3, and that's by a factor of 120. Now, if you didn't know that, you could have used your divisibility rules to simplify to get the 1/3. Now, 24 squared, that's 576. Being a geometry student, you should know that. And then 3 divides into 576 192 times. Now, you could divide that out on the calculator or by hand. It really doesn't matter. So that gives me 192, and I'm just going to keep this in pi for now. I'm going to convert my answer in a little bit because it does ask us to round to the nearest tenth. Now I have the area of the sector, I got to figure out the area of the triangle so I can subtract it. So let me get rid of this blue here. And we can start working inside this triangle. And inside this triangle, what we're going to do is we're going to draw in an altitude. We're going to draw in an altitude so we can calculate that triangle's height. Since I know the length of the side here, 24, because it's the radius, I know the length over here is 24. Therefore, this is an isosceles triangle, so these angles are equal. And since this is perpendicular to the base of an isosceles triangle, it also splits this central angle that's 120 degrees into 60 degrees. Therefore, this must be 30 degrees, and now we have that 30, 60, 90 special triangle in which I know the hypotenuse. The shorter leg, the side opposite the 30, is 1/2 of that. Therefore, the length here is 12. And then I can figure out the length here. The length from here to here is 12 square roots of 3. And this all comes from the idea of the 30, 60, 90 triangle. If you know one side, you can figure the other ones out. So, finding the area of the triangle now. I know the height of this triangle AOB, which is 12. I do know now the base, which is 12 square roots of 3 plus 12 square roots of 3, which is 24 square roots of 3. The total here is 24 square roots of 3. So the base is 24 square roots of 3, so I can find the area. Now the area is 1/2 the base, 24 square roots of 3, times the height, 12. We can multiply this out. It's pretty easy. 1/2 of 24 is 12. 12 times 12 is 144, and that would be 144 square roots of 3. So now we know the area of the triangle. So all we have to do is subtract them. To find the area of the segment, this shaded blue area up here, we have to take the area of the sector, 192 pi, and I have to subtract away from it 144 square roots of 3. This is what I'd put into my calculator. 192 pi, 3.14, or the pi key. I usually use the pi key, minus 144 times the square root of 3, and press enter. When you do that, and you round to the nearest tenth, it comes out to be 353.8 square feet. So that's how you find the area of a sector or a segment of a circle, finding the area of the sector and subtracting away the area of a related triangle.